This question is about atomic structure. In 1897, J.J. Thomson discovered the electron. He suggested that atoms were positively charged spheres with electrons embedded within them. Figure 1 represents an atom using Thomson's model. Suggests the identity of this atom. So if we count the electrons, 1, 2, 3, 4, 5, if we have 5 electrons and we're an atom, we must have 5 protons as well. So you want to go to the periodic table and find the element with atomic number 5, and that's boron. So this identity of this atom must be boron. Give 2 differences between the modern model of the atom and Thomson's model. Well, the modern model has protons in the nucleus at the centre of the atom rather than in as a big sphere of positive charge. In the modern model, electrons are in shells or energy levels around the nucleus. Other things now would be that neutrons are now in the modern model, and they're also in the nucleus at the centre of the atom, and that most of the atom is empty space in the modern model. Tellurium has a relative atomic mass of 127.6. Iodine has a relative atomic mass of 126.9. Define relative atomic mass. Well, relative atomic mass is the weighted average mass. Now, there are a number of different definitions, but this is the one that I prefer. The weighted average mass of all the isotopes relative to, so I'm going to use a divide sign, a fraction, a divide, relative to 1/12. Now, everything on this bottom line is super important. The mass of one atom of carbon-12. There's almost 4 things you need on that bottom line. 1/12, the mass, one atom, carbon-12. And then it says, suggest one property of tellurium that justifies its position before iodine in the modern periodic table. Well, the key to the modern periodic table is that it's arranged not in order of mass number, but in order of proton number. So if you were to look at your periodic table, you can see that tellurium, Te, has 52 protons, iodine has 53 protons. So Te has 1 less proton than I. Don't just say it has less. It has 1 less proton than I. You could say that Te has 6 outer shell electrons, whereas I has 7, and that's why they're in group 6 and group 7 respectively. That would also be acceptable. A sample of tellurium is analysed using electron impact ionization. That's the one where we use high energy electrons to knock off an electron. And the definition says when 1 mole in the gaseous state. So we're going to use high energy electrons to knock off an electron. We become a 1+ ion. And we've knocked off an electron in the gaseous state. In the time of flight mass spectrometer, an ion of an isotope of tellurium with mass number Y, so we've got a Y at the top here, travels along a 1.25 metre flight tube, that's the distance, with a kinetic energy, and it takes 3 × 10⁻⁷ seconds to reach the detector. Calculate the mass in grams of 1 mole, and then use your answer to suggest mass number. So the mass in grams of 1 mole will just be whatever our calculator says. A mass number needs to be a whole number of protons plus neutrons. So first thing that we can do, we've got a d and a t. Let's work out what velocity is. So distance divided by time. on your calculator. And that's a very big answer. So we want to see what that is. 4.17 times 10 to the 6 meters per second. We want to rearrange the expression for kinetic energy to say m equals. So m equals 2 times kinetic energy divided by v squared. So 2 times 1.88 times 10 to the minus 12 divided by the answer on our calculator screen. And don't forget to square it. So I'm going to use the fraction button. I'm going to type in the top line. And then on the bottom line, so I'm going to use the fraction button. I'm going to type in the top line. And then on the bottom line, I'm going to type answer and then squared. I'm going to see what I get. And that is coming out as 2.166 times 10 to the minus 25. Remember that this mass is in kilograms. So the first thing I'm going to do is turn it into grams by timesing by 1,000. So that's 2.166 times 10 to the minus 22 grams. Then to find it for 1 mole, I'm going to times by Avogadro's number. So I'm going to take my answer and times by 6.022 times 10 to the 23. And that's coming out to be 130.4. So the mass of 1 mole is 130.4. So the mass number, the nearest whole number answer, is 130. Tellurium has several other isotopes. 2 of these isotopes are 126 and 124. A different sample of tellurium is analysed using a time of flight mass spectrometer. Which statement about kinetic energy is correct? Well, this is just testing to see if you remember that all ions are given the same kinetic energy in the mass spectrometer.